Yeah, of course. Sorry. Yeah. I'm going to announce the last presenter in this session. It's José Badía, if I pronounce it correctly again.
Perfectly.
Because they call me Hakim in Spanish. Yeah, and I have the honor to announce his talk, Analysis of an Antenna Coverage for an Emergency Communication System. And it's my honor to announce probably the first on-time starting talk at this conference.
Thank you very much. I know it's difficult. It's the last session today. I'm trying to do it quickly. Well, I'm José Badía, and I'm going to talk about REMER, that is an analysis for antenna coverage for an emergency communication system. First of all, and these are the steps whereby earthquakes, eruptions, maybe twisters, hurricanes. It doesn't matter the origin of this. There are natural causes, of course, tsunamis, hurricanes, floods, but also can be some kind of violence or terrorism. It could be also we're searching for missing people. At the end, the authorities, the governmental authorities, have to make an actuation plan to resolve all of these situations. There are several steps, there are things to be done, but two of most important are communication and coordination. As I said, communication national authorities try to use all the available public resources to fight to these adversities. But sometimes, because the nature of the problematic they are fighting, not allowed to do it, to use all of these resources that they have, and they need to use the private support. I'm talking, for example, for the role of the amateur radio operators. Since in the middle of the 20th century, all the emergency communications are supported by most of the volunteers that offers their resources to make complete these communications when it's a catastrophe around a place. It has several strong points, such as the dispersed location along the national surface, or that they have a great ability to establish radio links in adverse conditions. They always are being called for the national authorities when exceptional circumstances justify it, but the most important thing, their job is always voluntary and altruistic. They do it and they not be paid for that. In Spain, all the amateur radio operators collaborated with Protección Civil, that is the entity that was in that situation, in that cases, since the 60s to the present. But was in 1982 when it formally conformed an organization that is called REMER, Protección Civil Emergency Radio Network. It is the responsible to share and to coordinate the force in emergency situations, combining the public and the private resources. Actually, it has more than 4,000 volunteers in this. Well, in the actuation plan, I said the communication is important. We got the radio volunteers. It's important to complete this situation, but also we need to coordinate them. How we can coordinate all the resources in this situation? Well, we have to evaluate what kind of resources we have, how are distributed. Now, for example, in communication, now the signal surface is covered, and identify the out-of-reach areas. More or less, what I'm talking about is something like that. We need a map, we need something that represents all the spaces, all the parts that are supported, we can communicate with, and which parts are out of reach of this communication. This is a heat map, but it's similar like that. Well, Protección Civil, in their conforming their network, develop or use the first software that they have to try to coordinate all these resources. The first one was the radio mobile that presents several advantages, like the first one is an online and desktop solution to try to do this, to resolve this problematic in a fine way. It's a free program and also works with the frequency range that they want to work, about 20 megahertz and 20 gigahertz. Also works with a digital terrain model, and it's important to make all the studies with most close to reality. But also, this software presents several inconvenients. First of all, is all the information that we try to put in has to be introduced manually. It can be imported from any database, and also it can be exported. It's a hard work to introduce all the information on this platform, this application. Also, we can always only work with the data we have inside the application. It means we can cross with more spatial data. We can cross with cadastral parcels. We can cross with roads or something like that. At the end, it's very old, this application, and the end the aspect design is outdated. It presents a poor usability and not very easy to use. It's here when we planned another solution for them. We present there the JVC Online Splat plugin, and this is why I'm going to talk about there. This section I have divided in 3 parts. First one to present the algorithm, because Splat is not a library that we have developed. It's something that already exists you can find in the Ubuntu repository, for example. I'm going to present the algorithm. And second, I'm going to introduce JVC Online for if somebody of you doesn't know. And at the end, I merge both solutions and explain how we put it in a plugin, all of this, and how it works with JVC Online. Well, here you have the explanation about what Splat means in propagation, loss, and terrain. And the first definition we have is an analysis tool for the electromagnetic spectrum between 20 megahertz and 20 gigahertz. It's the same that they are working with the other software. It's a great point for that. The second is that this algorithm produces report graphs and highly detailed, carefully notated topographic maps. It's one thing that the other one doesn't have. And also, it's free software. It supports the Virginia General Public License version 2. It's shared with the other solution. Another strong point that it has is that with that we can do the most important type of analysis of this kind of investigation, of this kind of studies. We can do a regional coverage, a path loss, a foil strength, a received power level analysis. I'm going to explain a little. I'm not an expert of that, but I try to do my best doing a small explanation of each one. Regional coverage analysis is very interesting for this material, for this aspect of the antenna coverage, because with that you can know all the places that you can see with the light of sight coverage that you see from one point surrounded about a radius. In the right part, you have a small graph in green and white that is not very good to see here. The green parts are the parts you can see from the middle, that is where is the antenna located. And the part white is the part that is not, you cannot reach with your view. It's similar if you go to the top of the mountain and you draw the parts that you can see from signs here. There are parts that you can see, and there are others that are behind of the mountains or behind of the buildings or trees that you can see it. It's similar. At the bottom on the slide, you have the command to, if you want to reproduce it using the terminal in Ubuntu, you can put this command, it can be reproduced. You need a digital terrain model, and it will be enough. Another type of analysis is the path loss. It means all the signal, for the only fact to be in contact with the atmosphere, are losing the powerful. It means how is the degradation of this signal along the space, from the center to the outside, along a radius you have planned. The output that we get is the same, is this TIFF, where is marked at different levels of signal in different points, at different points, and also we get the legend that we have on the right part. As you can imagine, if you put an antenna over the sea where there's nothing that make may be an obstacle for the signal, the results that we can get is something similar like this one that you are seeing here in this picture. On the right part, there's not obstacles between the origin of the signal and the end of the space studied, and it's all uniform degradation of that. In the left part, it crashes with other parts, maybe buildings, maybe trees, maybe mountains, and the signal will be lost. At the same of the first analysis, you get at the bottom the command to explain it, to reproduce it. There are other types of analysis, field strength, and another one, there's the received power level. It's something similar. The name makes us an idea of how it works and what is the main tool of this. But the most important, which applications have this kind of algorithms? When we have C1 for emergency systems, but for site engineering, for amateur radio communicators, also for everything that is related on television or radio broadcasting is very interesting. But the most important things is there are so many big organizations behind of this that support it and make it bigger and maybe more sure for that. One of them is the NASA and University of Massachusetts. That's important, and also all the community of amateur radio operators are behind of this. This is the first one, the first part I'm going to talk. It is about the SPLAT algorithm. Now we have a most clear idea what are we working with. Now I'm going to talk only a minute about GBC Online. I know everything of us are experts on it, but if you try to imagine first something about GBC Online, first image you get in your head is something like that. It's a geoportal with several tools where you can display information and spatial data on it. You can also work with alphanumeric information, and it's a way to make some queries or for make some petitions on it. But it's more like that. GBC Online is not only a geoportal. It's a complete spatial data infrastructure. It's a set of technologies, all of them open source, that divides all the solution in two parts, the server administration side and the web client side. On the server part, we have all the technology about the Django to provide all the part of the website, the PostGIF for the data, alphanumeric data, GeoServer to provide all the OGC services, GeoNetwork, LDA for validating users, and the web client, you can see a screen. All of have to be about open layers, GeoQuery, JavaScript, and something technologies like that. Well, we have both parts. We have GBC Online, we have a SPLAT algorithm if we want to merge in one solution, only one solution that we can be put it on the GBC Online software. There is when it's born this plugin, SPLAT plugin. I'm going to explain a little how it works, and it will be all. To make sure that everything goes right, you need a digital terrain model to start. It's the way that you can also make the analysis and to show if the signal will be lost or not lost, and all the obstacles that we can get in the signal. You have to define also several variables. You have there several of them. And the final return will be a GeoTIFF, not referenced yet, but GeoServer, GBC Online will be done for you, and the legend, as you can see at the bottom of this slide. I don't know if you can see it well, but it's a screenshot about the application of GBC Online, where you can define all the parameters that are needed. You have to define here the MDT model, where it's located, where do you want to be the output located at the end, and here you have to define the different parameters that are involved in these operations. Also, you can define the colors about the legend, more parameters, and the antennas that will be enveloped in these studies. At the end, the result something like that. It's all invented data, it's not real, but it makes us an idea about what are we talking about. In there, we can see different states for the antennas. Green are operative, red one if they are broke down, and then you can see there are parts that you can get a continuous signal to communicate from one place to another. Sorry. And that's all. That's our solution, the first solution that we propose to the customers. And there, what's the next part? What's the next step we're going to do? Well, Splat algorithm provides more things to do. It will provide more analysis type, provide reports, as I say at the beginning, and charts. We are going to try to introduce all of this in the plugin to be shown in your GeoPortal. We also want to automatize the process and increase the usability. At the end, what have we done is adding the Splat algorithm to GBSIC Online. And this allows us to join the functionality of the algorithm with the benefits of using spatial data infrastructure. With that, the results can be exported, can be imported. All of them are stored in a database and compared with other data, the cadastral data or roads or whatever you want. All information is stored in a centralized database, and at the end, it makes the declaration, validation, and checking process easier for all the professionals involved. I told you I'm going to be quick on this. Thanks for your attention.
This is how it looks when the session is driven by engineers. Do you have any questions? There is the mic.
So I have one question about if this is already being used by someone.
Yeah, as I said at the beginning, Protección Civil is the organization, public organization, governmental, who is managed for emergency situations in Spain. Okay. It's one important organization there.
Because here in Portugal, we have an issue about our emergency system that doesn't work, and it was very expensive. And maybe this could be something useful for...
We have to talk later.
not with me, but maybe with the government, I think.
Yeah, that's great because it shares all the powerful of the GBSIC Online solution. That is at the end is GIS Online that, with this specific tool, this specific plugin for the emergency system. And it can be adapted if they have other needs or other requirements for that.
It's just a comment to the last comment.
Okay, comment to...
yeah, because
I closed my mic.
I went to a workshop about KeyGIS in Lisbon about 1 month ago.
Yeah.
It was about forest defense from this Institute of Geographic Public. It's a university in Lisbon that studies these things also. There is a very... for the authorities, governmental authorities, there's a big concern about this, and they are doing something. KeyGIS have tools to do what our friend here told us. It's just algorithm application of some process from. You can do this, and it is people are studying this. They are. It was just a comment to a comment.
Yeah, I know.
More question? I would have one, maybe. GBSIC Online. If I understand correctly, the data were calculated online in GBSIC Online, right?
Sorry?
The map we could saw in GBSIC Online, that was calculated on the fly.
Not yet. You have to do a small calculations about the tips, and at the end you show the tips. The tips are the circles.
Yeah.
And this calculation is a strong part.
So there is no such application that one would click at new antenna.
You have to wait, but you can do it all the times you want.
Okay.
Because it's not immediately. You know, you can move an antenna and it's calculated.
And my question would be, are you using some kind of standardized web processing service, or is it just some your custom API?
For example, this example I have made to put in the presentation, all of this takes about 30 seconds. It's not so many times, but for online application, it's too much.
Still, are you implementing or using web processing service, or is it a proprietary solution?
Sorry?
Does OGC web processing service tell you something?
I don't understand.
Okay.
I talked you.
That is a response too. Thank you. So, in case there are no other questions, I thank you all. Thank you especially one more time. And we have lots of time to move to the main hall session for the keynote.